Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. For more details of the lectures, you can also visit our personal application. You can download our app. I have given a link in the description section. Today, I am going to discuss about the class 11's collision section. So, what is collision? Collision is said to be between two bodies, either if they are physically collide against each other or if the path one is affected by the force exerted by the other. For example, if an object is coming, okay, and when it collide with the another object, so what this when it gives exerts a force on each other, then that type of things are known as collision. So I will discuss more details in a collision. So first of all, I will discuss about elastic collision. See, elastic collision, what happens? See, if there is a mass m1 and m2, both having velocity u1 and u2. Suppose u1 is greater than u2, so what will happen? So collision will happen. So here it happens, and after that it starts moving in opposite direction. So this is the elastic collision. Okay, so proper definition if you want, so you can write here from here. So what is elastic collision? If there is no loss in a kinetic energy during the collision. For example, if an object is colliding with the another object, so what happens? There is a certain loss in the kinetic energy. But if there is no loss in a kinetic energy during the collision, then it is called an elastic collision. What is the characteristics of the elastic collision? Momentum is conserved. That is equal to m1 u1 plus m2 m1 u1 plus m2 u2. m2 u2 will be equal to m1 v1 plus m2 v2. I will show you details in this details. Okay. Total energy will be conserved. Kinetic energy will be conserved. Force involved during the collision are conserved, are conservative. Mechanical energy is not converted into heat, light, or sound. So in a fully elastic collision, so what happened in a elastic collision? So no extra wastage of energies like light, heat, sounds happen. Collision between subatomic particles, collision between the glass balls, etc. are the elastic collision. Example of elastic collision. Okay. Now I will talk about inelastic collision. What is the inelastic collision? If there is a loss of kinetic energy during the collision, okay, then it is called an elastic collision. For example, initially an object is moving with the velocity u1 and u2, u1 and u2. So total kinetic energy of this system before collision is suppose 1000 joule, and after collision, if there is a collision, after collision what happen, its velocity become v1 and its velocity become v2. So what will happen? Total energy will be how much? 100 joule. Okay. So characteristics of inelastic collision: the momentum is conserved, the total energy is conserved, the kinetic energy is not conserved. See here, initially kinetic energy was 100 joule, and after that 100 joule, then it is your elastic collision. But here the thing is that it is not 100, it is less than 100. So there is a loss in a kinetic energy, and this type of collision is known as inelastic collision. Some or more, all of the forces involved are non-conservative. In this, non-conservative forces are involved. Apart from mechanical energy is converted into heat and light. So when both will collide, so there will be a sound, there will be a friction between them. So there is a light sparking will be there. So in this way, we can say that there is a conversion of a mechanical energy is being converted into heat, light, and sound. So collision between two vehicles, collision between ball and floor. Mostly in our practical day-to-day life, most of the things, 99% we can say that the collision are inelastic. Okay, in an elastic collision there is a loss of kinetic energy, so very important, loss of kinetic energy happens, but in elastic collision no loss is happening, right? So I hope you have understood in elastic collision. Now next is your perfectly inelastic collision. So if two bodies stick together after a collision and move in a single body with the common velocity, then the collision is said to be perfectly inelastic collision. For example, you can take a mud, okay, and another mud is there, mud. So what happens when you throw this mud? to this ball, so it will get stick, and they will act as a single particle and single entity, and they will move with the velocity, single velocity. And such a collision is called perfectly inelastic collision. In such a collision, momentum is conserved but loss of kinetic energy is maximum. In this, maximum loss of kinetic energy will happen. In such situation, if an object is coming with the velocity, and if like mud, and there is a wall, what will happen? It will get stick here. It means that there is a zero kinetic energy after sticking. So mud thrown on the wall and sticking to it, and a man jumping into a moving trolley, bullet is fired into the wooden block and remain embedded in it, is the example of perfectly inelastic collision. Okay, so these are the type of inelastic collision. So before going to discuss more details about the collision, so I want to clear up conservation of linear momentum. So you should try to know what is conservation of a linear momentum. Okay, let us discuss. See, suppose two bodies, one and two are collide against each other. So this is a body 1 and this is a body 2, and they will collide each other. See here, there is a collision. After collision, it goes in a opposite direction. Okay, so they will exist in a they will exert mutual impulsive force. They will exert mutual impulsive force. Mutual impulsive force, right? Impulsive force. Okay, they will exert a mutual impulsive force to each other. Now change produced in a momentum of our two bodies. So earlier, see, earlier what was the momentum? See, change in a momentum is in this object. See, there is an object 1 and there is an object 2. So change in momentum of an object 2 can be written as delta P1 is equal to F12 into delta T, because it is an impulse, and impulse is also a change in momentum. We have already discussed that impulse can be written as impulse can be written as okay, wait. Impulse can be written as why it is not working? Sorry. Impulse can be written as, okay. Come on, huh? Impulse can be written as, see here. Impulse can be written as change in momentum, right? So that is initial momentum and final momentum. And change in momentum and impulse is also defined as a force into short term time. So change in impulse for 1 and change in impulse for 2 is equal to, can we write here this, force on 1 due to 2 and here force on 2 due to 1. See, when a force is being applied on the body 1 by the 2, and the change in momentum can be written as F12 into delta T. Similarly, change in momentum in a body 2 can be written as force into 1 into delta T. Okay, right? And here we can see here F12 and F121 is what? F112 is force applied on so we can see here that the F12 is what? F12 is force applied on an object due to 2, and F21 is the force applied on an object 2 with respect to 1. As per the Newton's third law, every action has equal and opposite reaction. So F12 will be equal to negative of minus F21. So here Can we multiply by del t? So we have multiplied by del t both the side. So what we are getting here? We are getting here what we are getting. So can we write here f12 into delta t plus f21 into delta t is equal to 0. That is equal to delta p1 plus delta t2. This is equal to 0. If I will take delta in a common, so p1 plus p2 is equal to 0. So hence, if we can see here that the linear momentum of the system remain conserved. Okay, so total momentum should be 0 always, right? So in this way we can say that linear momentum of the system is conserved. Now I will talk about the elastic collision in one dimension. What is one dimension? Means only one axis I will use here, either in a x axis, either in a y axis, whatever. So let us consider this is an x axis. Okay, this is an x axis, and it has a mass m1 and u1 as a initial velocity, and condition of a before collision. Okay, it is a condition of a before collision, and m1 and m2 after during the collision, and this is your m1 and m2 after collision, right? After this, the condition of after collision. Okay, now as per the conservation of momentum, as per the conservation of momentum, as per the conservation of momentum, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So here m1 u1 minus m1 v1 is equal to m2 v2 into v2 minus u2. So we can write here m1 common u1 minus v1 m2 v2 minus u2. Okay. Also, since it is a elastic collision, so kinetic energy will be conserved. That is initial kinetic energy of the system. We always talk about the whole system, particle 1 and 2 as a whole system. So what I have to do? 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square. That is the initial kinetic energy. So this represent initial kinetic energy of the system, and this is a final kinetic energy of the system. So initial kinetic energy will equal to in final kinetic energy, because this is this is an elastic collision, and in elastic collision kinetic energy is also conserved, right? Now I will talk about it. Okay, so when I cut this, and we will get m1 u1 square minus b1 square is equal to m2 b2 square minus u2 square. So finally what we are getting, here, finally see here, finally we need to put the value. See here, divide equation 2 by 1. So this is the equation 1, and this is the equation this is equation 2, and this is the equation 1. So divided by 2 by 1, so we will get like this. See here, m1 if a minus b whole square, so you can write u1 minus b1 plus into u1 plus b1 divided by m1 into u1 minus b1. So this got cancelled, and also here same way m2, that is your v2 minus u2 into v2 plus u2 divided by m2 into v2 minus u2. So this got cancelled out. So finally we are getting u1 plus v1 is equal to u2 plus v2. Okay, so if you will do this, so finally we can rearrange this. So we will get u1 minus u2 is equal to v2 minus v1. Okay. Now can you imagine what is u1 minus v1? Sorry, can you imagine u1 minus u2? Can you imagine this? So u1 minus, actually u2 is what? It's u1 is the initial velocity of object 1, and u2 is the initial velocity of object 2. So can we write here relative velocity of 1 with respect to 2, that is velocity of approach. So can we write here velocity of approach, and v2 minus v1 is what? v2 is the final velocity of an object 2, and v1 is the final velocity of an object 1. So this is your velocity of separation. Definitely how much, see here, it is a, suppose this is a v1 is going this side and v2 is going this side. So V2 minus V1 will be what? V2 minus V1 will be what? So it is the relative velocity of a separation. Okay. So finally, relative velocity of approach is equal to velocity of separation. So we can get some uh, conclusion that velocity of approach will be equal to relative velocity of separation. Okay. So from here we can write here V2 is equal to V1 plus U1 minus U2. Okay. So now M1 plus M2, as we know that M1 plus M2, M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2 because momentum will be conserved. Okay, as earlier an object see if you want to see the object, see here, if you want to see the object, I will show you an object. Hmm, is it? Sorry, due to some technical issue, it's not working. I think. Okay, no problem. But I will try to give you. Yeah, see. This is your mass M1, U1, and M2, U2. So what will be the momentum as per the momentum before collision M1 U1 plus M2 U2. After collision M1 V1 plus M2 V2. I hope you have understood now. So this is what we have got an equation. Okay. So this equation, see here, what I am doing actually I am putting the value of this V2, right? So I am putting the value V2. I am putting the V2 value V2 from where? In equation, from equation 3. Okay. So this is the equation 3. So we have got this equation. So after solving the equation, after solving equation, see here, after solving equation, see M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. In place of M2 V2, it will become M1 V1 plus M2 U1 minus M2 U2. So we will rearrange this. When you will rearrange this, so what will happen? You will get velocity V1 is equal to U1 M2 minus M1 divided by M1 plus M2 and minus 2 M2 by M1 plus M2 into U2. As a mathematician, you should know how to rearrange this. Okay, I hope you have understood this. So this is the derivation of the velocity of object 1 with respect to the initial velocity of the object. See here, initial velocity of the two body U1 and U2 I have used. So we have got final velocity by just using mass only. Okay. Now let's we will get similar value. See here, we can get similar value. What we have I have done, see here, in place of V1 we have changed V2. In place of U1 I have changed U2. In place of M2 I have changed M1. In place of M1 we have changed M2. Minus in place of M2 we have changed M1. So just change the subscription, so you will get the final velocity. So this is a very easy. Okay. So I hope you all have understood now. Now, now let us come for collision in a two dimension. Okay. So what is actually the collision between two dimension? So two dimension means what? They will use at least x as well as y axis. So when a collision happens, see, let us consider this is a object. Okay, this is a object, and this is also an object having mass m1, having u1 at a velocity u1, and this is at a rest. So when it comes and collides, so they will go in a different direction. So let us consider m1 will go in this direction, okay, and m2 will go in this direction. So m1 is making a theta 1 and m2 is making theta 2. So you can also resolve this component in two component. So can we write here v1 cos theta and can we write here v1 sin theta? Here also v2 cos theta and v1 sin theta 2. Okay. So Can we see, we can see here what is initial momentum. Initial momentum of total system was m1 u1 plus m2 u2, but u2 is what, at a rest, so it will become 0, so it is initial momentum. And initial momentum in x direction, I am talking about x direction only, right? X direction, I am not talking about y direction. So in x direction final momentum is what, see here, final momentum will be what, final momentum will be what? So it is your uh, m1 into v1 cos theta. So I have written this. It is also m2 into v2 cos theta. So I have written this. So total momentum, initial momentum in x direction is equal to initial momentum in final momentum in y direction. Sorry. Initial momentum in x direction is equal to final momentum in x direction. Now I am talking about y direction, since an object is not moving in y direction at all initially. Now, so total momentum in y direction will be 0 at first. But when they collide each other, so they went for a y direction as well as. So can we write from here that total momentum before collision in y direction is 0, but the total momentum in y direction after collision is what, m1 v1 sin theta 1 minus m2 v2 sin theta 2. You think that why I have written this? See here. See, if its velocity component is in above direction, so that is m1 v1 sin theta, it is a positive, and m2 v2 sin theta 2, it is a negative. So I have taken this. Okay, I have taken this, and so we have got this equation. So in this way you will able to solve so many numericals and all. You can understand how we can use this type of equations to solve the different type of problem. Different type of unknowns are there, so if we get two type of equation, so we can use this equation. Okay, apart from this I can also use here kinetic energy is also conserved. For example, if I will take about kinetic energy, so kinetic energy will also be conserved. Okay, kinetic energy, initial kinetic energy is what, half m1 square, half m1 into v1 square. Sorry, it will be u1, right? It is initial. So you should use here, m1 into u1 square, and this is equal to final kinetic energy will be what, 1 by 2 m1 v1 square plus 1 by 2 m2 into v2 square. Okay, so I hope you have understood me. This is m2. Okay, I have I hope you have understood this equation, right? Now I will talk about the coefficient of restitution. What is exactly the meaning of a coefficient of restitution? The coefficient of restitution gives me the measure of a degree of restitution. It is the ratio of magnitude of relative velocity of separation to the after the collision to the magnitude of the relative velocity of approach. Whatever I have talked about. So E can be written as v1 minus v2. That is the velocity of separation, magnitude of the velocity of separation. This is a velocity of separation. This is a velocity of separation divided by velocity of approach. Okay, so you will get the value of E. Now, if you are getting a value of E is equal to 1, so you can understand that it is an elastic collision. Okay, and if you are getting velocity of value of E is between 0 to 1, so you can imagine that this is inelastic collision. And if E is equal to 0, so we can say that perfectly inelastic collision it is. Now I will talk about super elastic collision. So what is super elastic collision? So super elastic collision, that is equal to E is greater than 1. E is greater than 1, so we can say that it is a super elastic collision. Okay. So I hope I have completed all the topics in the collision, and these things should be used in solving a numerical problem. So I will come with another video with the power topic. So I hope you will wait for my video, and I will teach you power, and in this way we will end the work energy power chapter. Thank you everyone.